Okay, guys, welcome to another lecture. Today, what I want to do is we're going to finish up talking about number systems and codes. What I'm going to do in the live stream is cover one of the PowerPoints. I also made a video of that PowerPoint. So today, what I want to do is talk about binary arithmetic. There are some other PowerPoints. I think there's 3 of them. So there'll be one that follows this lecture. So you can, I think by me doing this live, it will just make the PowerPoint make a little bit more sense to you. But the other 2, I'm not going to make a live video. Just look at those at your leisure. So make sure I say by Monday, you've looked at all the PowerPoint videos that I put up, and I'll put that up sometime tonight or in the morning. Also, if you haven't noticed, I posted a new homework assignment, homework number 3, which deals with binary arithmetic. Right now, you don't know how to do it, but after we get done with this lecture, you'll see how to do it. It should be pretty simple. I think that's it. You do want to, I think I might have mentioned in the video, or maybe last lecture, if you hadn't gotten your lab manual yet, you want to start thinking about at least looking around for one. I will make a copy of the front cover of the one that I have. You can get the ISBN number off of that, or just go by the picture. Just make sure it says lab manual on it. I mentioned before that all the books by this author look alike. There's a lab manual, activity manual, and a textbook. They all look the same, so it's easy for you to purchase one thinking you're buying the lab manual. So just be sure it says lab manual on it. It may or may not have a CD with it. If it does not have a CD, I'll provide a link for you where you can download the software. You don't need it right now, but week 6, we want to hit the ground running. So just to make sure you can get a book and don't have any software issues, start looking at that. And then we need to start thinking about an exam. I don't know if I mentioned it already, but exam 1 will be over weeks 1, 2, 3, and 4. So I'll put more information about that up a little bit later. So right now what I want to do is I want to talk about binary arithmetic. Now, the reason we're doing this is you don't have to become an expert at this, but we've been looking at a little bit of this computer science stuff, digital information. What happens to information when I go from analog to digital and I get inside the machine? I have to deal with zeros and ones. You know, everything that's recorded or stored as a 0 or 1. But one of the things that you can do with a PLC or other machines like your cell phone or PC, you can do mathematics with it, arithmetic, and higher level math. So the purpose of this is to just give you an idea of what's going on inside the machine, how it handles binary numbers. So I want to go over a few examples, and this should be kind of a short video because, as I said, the PowerPoint, make sure even though we're going over this live, you go through the PowerPoint because there will be some things that I talk about in the PowerPoint that I don't talk about here. So we're going to look at addition, subtraction, and multiplication. We could do division. Division is not really that difficult, but just to kind of let you see what's going on, we'll limit it to addition, subtraction, multiplication, and that's what you'll be responsible for on any quiz, test, or exam. And if you want to know more about it, we want to go into division or some other stuff, I'm happy to do that off camera when we're not recording. I don't mind going over that. If some people have interest in this stuff, I can go into some more details. But we'll just keep it basic for now. So what you see here, and I sent out a couple PowerPoint slides for you guys to take notes on. I did not send the one for this yet. I'll send that directly after I make this video. The reason I didn't send it out is because I'm going to give you some practice problems, and the answers to the practice problems that are on the PowerPoint. And I want you guys to focus on the problem, not look at the answer. So I'll send that out, and you'll have a copy of that to add to your 3-reading binder. But what you see here are rules for, now these are binary numbers. I didn't subscript them, but it says binary here. So remember, now that we have multiple number systems that we can deal with, you got to say what kind of number it is. So you can put a little 2 right there as a subscript. Or it has to be clear to me that we're dealing in binary, so I wrote binary there. So it's understood now that everything I'm going to do here is in binary. And what I want to look at first is binary addition. I want to look at binary addition. So I have the rules for binary addition right here. And so if I look at this, in binary, or really in any number system, a binary 0 plus a binary 0 is a 0. A 1 and a 0 in binary is a 1. A 0 and 1 in binary is a 1. Now you got to be careful with this. In any number system, a 1 and a 1 is a 2. But in binary, a 1 and a 1, and the way I got it right too, is a 1, 0 base 2. So if you remember your 8421 code from the last video, you can get the weights. This has a weight of 8, 4, 2, 1. So the way I would write a binary 2 is I need to put a 1 there over the 2. So 1, 0 base 2 is the way I write a binary 2. So often what you'll see when you see this one here, they'll go, a 1 and a 1 is a 0, and the 1 they'll write off to the side, and they'll call that a carry bit. That's called a carry. So I'm just writing it here so you can see that it's equal to 2. So just remember, a 1 and a 1 is a 2, binary 2. So keep this in your mind, and what you really want to have for this, what we're doing now, take out some scrap paper, and what I want to do is you look at these rules, and I'm going to give you a problem, and I'll give you a problem in a decimal. We'll convert it over to binary, and I want you to add it in binary, just so you can see how it's done. So I'm going to, I guess I can just start right here. I'll keep the rules on the board. So for the first problem, you're going to see the paper, and what I've done is I pulled the practice problems right off the PowerPoint, so you'll have a record of this, but I want you to go ahead and go through it. So we have, this is a base 10 number. We got 5 base 10, and we got 2 base 10. And I add those up, of course, I'll get a 7 base 10. Well, in binary, convert that to binary. In binary, this is a 1, 0, 1. And this would be a 1, 0. And what I want to do now is add these up using those rules in binary. So if you got scrap paper, go ahead and get your paper out. I'll pause for just a second. Apply those rules to this, and then I'll give you another problem. So give you just a second to get yourself together if you don't have a scrap paper out already. So the way to think about this, just apply these rules. I guess this green will show up. I don't know how it shows up on the camera. But so going by those rules, a 1, let me do it in black. A 1 and a 0, according to those rules, is a 1. A 0 and a 1, according to the rule, is a 1. And then this one, I just bring it down. So by adding a binary 0, 1, 0, 1, 0, 1, and a binary 2, I get a 1, 1, 1, which if you check is a 7. So for that, it works out. So that's the kind of thing you want to be able to do. So it's pretty simple to apply the rules. So there's one example. I'll give you another one. So write this down. The next one is I got a 10 and a 3. I'm going to add those up. So this is my base 10 over here. I won't subscript it. I'm going to add those up and get 13. So what I want you to do is convert that to binary, apply the rules and add it up and see if we do in fact get 13. So convert 10 to binary and convert 3 to binary. And if you convert 10 to binary, think about your 8, 4, 2, 1. You need an 8 and you need a 2. So this is a 1, 0, 1, 0 base 2. And then here's my 3, and I want to add those up. So see if you can take this and apply the rules to it, and let's see what happens. I go a 0 and a 1. If I add those, I get a 1. Now, here's where you got to be careful, because this next one, a 1 and a 1, I got to apply this one, right? So a 1 and a 1 is a 0, carry 1. That gives me the 1, 0 for 2. So I say a 1 and a 1 is a 0, and then I got to take the carry and put over in that next column. Carry 1. And I go 1, 0, that's a 1. And then this 1 I just bring down. So I have a 8, I got a 4, that's 12, and 1. I do get 13 base 10. So that works out. So that idea of carrying, just like regular arithmetic, you can carry over to the next column. It's the same type of thing. So really, once you, if you kind of compare this to what you do with regular arithmetic, you can kind of figure this stuff out. It's not difficult at all. So there's an example. I got one more example I'll give you. Um, 26 base 10 and 12. Okay, we're going to add those up, and then I want you to convert each of those to binary, and then add those up. So I get 38, but I want you to convert this to binary. Convert that to binary, and convert that to binary, and then we'll add those bits up. So there's what we're adding. And I'll add the 0 and the 0 and get a 0. A 1 and a 0, get a 1. A 0 and a 1 and get a 1. And now I got to carry again like before. So I have a 1 and a 1 is a 0, carry 1. And now I got to carry again. I got a 1 and a 1 is a 0. And I got to carry that other 1. So I get a 1, 0, 0, 1, 1, base 2. So homework 3 deals with this kind of stuff. There'll be some addition, subtraction, multiplication. Just practice stuff and get you ready for the quiz and the exam. So those are the rules for binary addition. It's pretty simple. Doesn't get any harder than this. So if you can handle this, I think the rest will be all right. Now I'm going to put the rules up. We'll get rid of this. And I'm going to put the rules up for subtraction. So this is binary subtraction. All right, so we have a, oh, by the way, before I do this, just let me show you something real quick. So those rules for, this stuff is actually done by logic gates. I think I might mention this in the video, so maybe I won't go over it. But I'll show you at a later time that you might wonder how is the circuitry actually doing this. Well, it turns out that multiplying and subtracting and adding, you can do that with tables. I'll show you that here in a second. Let me go ahead and put the rules up. So I got a 0, take away 0. I got a 1, take away 1. I got a 1, take away 0. And I got, now this one is a 1, 0, which is a binary 2. And I'm going to take away 1. So in any number system, of course, a 0 minus a 0 is a 0. A 1 minus a 1 is a 0. A 1 minus a 0 is a 1. Now this says a binary 2. I have a binary 2. If I take 1 away from 2, I get a binary 1. So there are my rules for subtraction. So given those rules, the example I have, I got a 3, a 10, and a 2. Of course, you're going to subtract those. No, that's a 1. I'm sorry. I'm going over the ones that I have on the PowerPoint so you can see what I'm doing. And so the one I have is actually a 1. So that's a 1. And you'll get 2. So convert this to binary and convert that to binary. So for 3, convert it over, I got a 1, 1, base 2. And here I have a 1. I like to, just to keep the same number of bits, you want to remember that these numbers are actually stored in the register. So you can write that right here without that leaving 0. But if you think about where these numbers are stored in the computer, I gotta have at least to store this. I gotta have a register with at least 2 cells in it. Now you won't find a register with 2 cells. It'll have more. It'll probably have like 8 cells or more. It could be bigger, depends on the word size. But let's say I have a register, because these numbers are stored in registers, and I have this number 3. Well, I'll just show us. We got 2 digits here. Let's say we did have a 2-cell register. So the number 3, if it's stored in that register, it's stored as a 1, 1. Well, over here in the second register with the 2 in it, you can't really just put one binary digit there. It doesn't make sense. When you have a cell in the register, it's got to have something in it. So it's got to be a 0 or a 1 in it. So you really want to just kind of get used to just, if I have however many columns I have, you want to make sure each number has the same number of columns. Register, you couldn't just say there's a 1 there. There's got to be something over there. So you would put a 0 there. Not that big of a deal, but just to show you, that actually does come up when we do 2's complement subtraction, which I'll show you in just a second. So apply these rules, and if I apply the rules, I got a 1 minus a 1, that's a 0. I got a 1 minus a 0, that's a 1 base 2. If you check it out, that is in fact 2 in the binary. So that's a pretty simple example. So let me give you another one. You work all the way through it. I'll be quiet for a minute and give you a chance to work on it. I got a 3 minus 2 this time. So I got a 3 base 10, take away 2, base 10, I'll get a 1. So convert that over, apply the rules, and let's see what you come up with. See if you get the right answer. So if you convert this, I get that. If I convert this, I get this. And I want to subtract them. So I go, if I have a 1, take away 0. If I have a 1, take away 1. So a binary 3 minus a binary 2 gives me a binary 1. So that checks out. Now, what happens if you have this? Suppose I had, let me see, how can I show it to you? If I have this, if I have, let me see, I take 534 minus, I don't know, let's say 61. So if I would do that, these are base 10 numbers. What you would do is you say, okay, that's simple. What I got to do is I got to take 4, take away 1. That gives me a 3. I got a 3, take away 6. You say, oh, I can't do that. I can't. So what I got to do is come over here. I'll borrow 1 from the 5. I'll change that to a 4. Knock that down by 1. And that 1 comes over. But when that 1 comes over, it doesn't come over as a 1. It comes over in the 10th place, which makes that a 13. So I can borrow when it comes over as a 13. Well, I can do the exact same thing. It's the exact same thing in binary. This next example will show you that. So I'm going to give you I'll give you 5 minus 3. All right, of course, we'll get 2. But go ahead and convert that over to binary. Do the subtraction with those rules. And you got to think about what we did right here. You got to borrow. So see if you can figure out how to do that. Convert it over, do the subtraction, see if you can think about how to borrow. So when you're doing this problem, you got to think about this rule. When you have a 1, 0 and take 1 away from it, you got a 1 left. So what I got to do here is, well, this one's no problem, right? I can go 1, take away 1. That's a 1. But when I say 0 take away 1, that's like I had 3 take away 6. You can't do that. I had to come over here and borrow 1, but that 1 made this a 13. I do exactly the same thing here. I say 0 take away 1. I can't do that. So I'm going to come over here. I'm going to borrow 1 from here. So I got to knock it down by 1. I knock this down to a 4. I got to knock that down to a 0. It can only go to a 0. But the 1 I borrow comes over here, making this a 1, 0, making it a 2. And so now I can do the subtraction. I say I got a 1, 0 minus 1. Well, that's just this rule right here. That gives me a 1. And I got a 0, take away 0. That gives me a 0. So I got a binary 5, take away binary 3, gives me a binary 2. The point of this problem is, though, understanding how to borrow. You can borrow. So look at that, make sure you understand it. I want to give you one more where you got to borrow. So take out your paper and write this down. See if you can do this problem. If you can do this one, I'm happy. So suppose I gave you one, 1, 0, 0, and 1, 0, 1, 1. And I want you to subtract these two. So subtract, these are binary numbers. So subtract these two. And see if you understand the borrowing. Now you got to borrow a couple times for this problem. So it's the same thing we did here. Now I have, while you guys are working, so I do not want what some students will do, they won't learn the rules. What they'll do is they'll convert this to decimal, convert this to decimal, subtract it, and convert it back to binary. And I don't know how I'm going to stop you from doing that, but you really want to learn the rules. So I want you to apply the rules of this. Don't convert it to decimal. Learn what the machine is doing. So if I dive into this one, what I'll have is, well, I got 0 take away 1. I can't do that one, so I got to borrow 1 from here. The problem is I don't have 1 there to borrow. I have a 0 there. So what I do is I come over to this one. I borrow 1 from here. So if I borrow 1 from here, this becomes a 0, and that 1 comes over. And I hope this red shows up in the camera. I don't know if it shows up. So I'll knock that down by 1. The 1 I borrow comes over here as a 1, 0. So that's a binary 2 right here now. So now what I can do is I can borrow 1 from this whole thing, right? From that 1, 0, I can borrow 1 from that. So I can say, I want to borrow 1 from that, bring it over to here, makes this a 1, 0. But when I borrow 1 from a 2, there's still 1 left there. There's 1 left over. So hopefully that doesn't confuse you. A 1, 0 minus 1, that gives me a 1. A 1 minus a 1 gives me a 0. A 0 minus a 0 gives me a 0. And a 1 minus a 1 gives me a 0. So the answer we have, if I take a 1, 1, 0, 0, it's at a 12. And if I take the difference between these two, I get a 1. So the borrowing, you can get a little confusing, but I don't think it's that bad. I mean, I think you guys can figure that out or look online and practice this before you turn in the homework. So, now there is another way to do this I want to show you. Here's the thing about this. I don't know if I mentioned this already, but all of the stuff that we're doing here, and just if you think about your calculator, you can multiply, divide, you can do division, subtraction. But really, if you think about it, think about what multiplication is. If I say I'm going to take, I don't know, 4 times 3, you know that's 12. You know the way the computer would do it is it'll just take 4, it'll take this and add it up this many times. So let's say 4, 4, 4, and it'll add that up and it'll get 12. You'll think it's multiplying, but it's really adding because it's so quick. So what I'm saying is a computer, there's these chips. You got to have a chip to multiply. You got to have a chip to divide. You got to have a chip to subtract. You got to have a chip to add. And I'm showing you, you don't really need the chip to multiply because if you have an adder, you just add up the numbers and the computer or the device is so fast, it can add it up and you think you're multiplying. And it turns out really, if you think about when you divide, let's say I take, same kind of thing with the division. So I'm going to take 12, I'm going to divide it by 4. All right, so you know it goes 3 times. But all division is a fast way of doing subtraction. Because what you're really saying is, I want to see how many 4s is there in a 12. So you say, all right, I got 12. I'm going to take 4 out. That's going to leave me 8. So I know I got 1 4 in there. And I'm going to take another 4 away from it. That's going to leave me 4. So I know I got another 4 over here. I'm going to take 4 away from that. I don't have a remainder here. So that means I got 1, 2. I got 3 of those. And so the point I'm making is that when you think you're dividing, your calculator can just subtract real fast and you think you're dividing. So I don't really need the multiplying chip and I don't need the division chip because I can do division and multiplication and subtracting. Well, what's mind-blowing is you don't even need the subtraction chip. You can just use an adder. Because if you think about this. Think about this. I can have, let's say I take 7 and I take away 3 from it, that's 4. So I got that subtraction sign there. So I got a chip or circuitry that subtracts. But what if you did this? What if you said 7 plus a negative 3? Now the operation I'm doing is addition. I add the opposite, the negative of it, I still get a 4. So you can see you can actually do a subtraction in terms of addition if I can deal with a negative number. Well, if you saw the last lecture, we saw ways to represent negative numbers in binary. There's a problem with binary because we can only deal with 0s and 1s. So if you looked at that last video or you were present for the lecture, we talked about 3 different ways to represent a binary number in a machine, a digital machine. One way to do it is to use a sign bit. So I showed you that. The second way was to take the 1's complement. So just to remind you how to do that, the 1's complement, if I have a binary number, say I got 1, 1, 0, 1, 1, 1. The 1's complement says, all right, I'm just going to flip the bits. This is the original number. The negative of it, represented by the 1's complement, will be a 0, 0, 1, 0, 0, 0. All I do is flip the bits. That's the 1's complement. So that's one form of a binary negative number. The 2's complement, though, which is important for us, is another way to represent a negative number. So let's say, well, I'll just use this one since I already have it up there. Let's say this is my original number, and I want to take the 2's complement of it, which is a negative form of this number. The 2's complement, to do that, what you do is you start over to the right, and everything over to the first 1, you leave alone. So everything from here to here, I'll leave alone. I won't change it. I'll write it as it is. So I go 1, 0, 0, 0. Everything after that 1, I'm going to take the 1's complement of it. I'm just going to flip the bits. So that's a 1, and that goes to a 1. So this right here is the 2's complement. of that number. So that's a form of a negative number in binary. So I'm showing you that to say we can get rid of the subtractor circuit if I can subtract by adding or subtract in terms of addition, subtract in terms of addition. I can get the same effect and just have one chip to do all my math, adder. And so it turns out that we can do that by adding the opposite. So let's do that with this since we already know what the answer is. So what I'm saying is, I know if I take a 1100 and a 1011 and subtract, I get a 1. But I should be able to take this number and add the negative and also get that number. That would be exactly what I did before. I took 7 plus a negative 8 and got the same result that I would get if I just directly subtracted a 3 from 7. And so let's try it this way. This is called two complement subtraction. Doing subtraction in terms of addition. So what you would do is you start out, we got this number. So I got a 1, 1, 0, 0. Now what I got to do is take the 2's complement of this number. So let's do that. So I got this. Now you take the 2's complement of that. I'll pause for a second. I think I'm moving kind of fast. Take the 2's complement of this. And if you do that, up to and include the first one, you leave it alone. So that's the first one is a 1, so I leave that alone. Everything after it, I flip the bit. So this becomes a 0, this becomes a 1, this becomes a 0. So this is the negative of that in 2's complement form. So I should be adding this, and that's exactly like doing subtraction in terms of using addition to do a subtraction. So I'm going to now add that to this. Let's see what happens when I do that. So I'm adding the negative now. So I got 0, 1, 0, 1. And I'm going to add these. So I'm adding the negative. When I add these, I get a 0 and a 1. Well, that's a 1. I get a 0 and a 0. That's a 0. I get a 1 and a 1. That's a 0 carry 1. So I got a carry 1. I get a 1 and a 1. That's a 0 carry 1. A 0 and a 0 is a 0. And then I got 1 out here as a carry. And you say, uh-oh, it didn't work. These are different numbers. One there, I don't want to have one over here. Well, it turns out when you use this 2's complement subtraction, if you get a carry, you just throw it away. And you only look at this part of it. So we can actually do pretty much all this math with just one chip, an adder. We can do everything in terms of addition. So that's pretty interesting if you were to get into this stuff, really deeply how it's done. Okay, so that was pretty simple. I don't think that was too bad. So we've done addition, subtraction. I showed you an alternate form of subtraction called 2's complement subtraction. I want to show you one more thing, and then that'll be it. We'll be done. I want to show you multiplication. And then I want to show you real quick that you can actually do this with circuits. So I'll just show you something real quick. So let me show you, get the rules up here, and then we'll do a couple problems, and we'll call it a day. So this is binary multiplication. Okay, so the rules are 0 times a 0, and these are all binary. This is base 2. This is, of course, 0. A 0 times a 1, well, that's a 0. A 1 times a 0, that's a 0. A 1 times a 1, well, that's a 1. So those rules are really simple. So then if I give you a problem, let's do this one. 3 base 10 by 1 base 10. I want to do that. Of course, it's 3. We'll go ahead and convert it over to binary. Do it using the rules right there. And if you do it using the rules right there, you get a 1 and a 1. You got a 1. And if I multiply a 1 times a 1, that gives me a 1. A 1 times a 1 gives me a 1. So a binary 3 times a binary 1 is a binary 3 like we would expect. So nothing earth-shaking there. But try this next one though. Try this one. This will be a little bit more interesting, I hope. What if I gave you 3 times 3? Do that one. So we got a 3 by 3. And I'm going to multiply that, and of course we're going to get a 9. But do that in binary. How would you do that in binary? Do it in binary. Now, if you do it in binary, there's one little step that you probably already figured out. You guys are so smart. But what you got to remember to do is to shift the column over when you multiply by that second number or second digit. So you say a 1 times a 1 is a 1. A 1 times a 1 is a 1. But when you do this one, 1 times a 1 is a 1, you got to shift it over like you're doing regular multiplication when you do it with base 10. So 1 times a 1 is a 1, but I make sure I put it over here. A 1 times a 1 is a 1. And then this one just comes straight down. So I get a 1. This one I get a 1, and the 1 is a 0, carry 1. So that's a carry. I got a 1 and a 1, that's a 0, and I write my carry over there. So I got a binary, if I use my 8421 code, that's an 8, that's a 1, that's a 9 in decimal. So when you multiply, you got to remember to shift it over. So that's really all I have for this. I do want to tell you one more thing, because you might say, well, okay, Ron, I see this with these zeros and ones, but really, we're really doing this with voltages, the presence or absence of a voltage. And how is this done? I mean, what really is the machine doing? Well, look at this real close to see if you see a pattern here. Look at the rules. It's the same for addition. I can show you. I'm just going to use multiplication because we got it up here. If you look at that close enough, it should remind you of something. Now, I'm going to let you think about it. Anybody see anything interesting about these numbers? What if I do this? What if I say we got A, B, X, and I say this is false, false. And the way you do it, if you got two variables, we alternate. Remember, this is false, true, false, true. This is false, 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 true, true. And if you look at the and logic that we talked about, the only time the and is true is when both input conditions are true. For every other row in the truth table for and, it's false. So I want you to imagine over here, instead of using trues and falses, what if we use a 0 for false and we use a 1 for true? So let me redo the truth table. Here I have 0, so that's 0, 0. Here I have a 0, 1, so that would be 0, 1. Here I have a 1, 0, so that would be 1, 0. And here I have a 1, 1, so this would be a 1, 1. So I can show my and. This is the way we'll do it from now on. Really, I'm going to show up with zeros and ones because that's what we deal with, zeros and ones. And for and, then my output would be, this is a 0, that's a 0, that's a 0, that's a 1. Look at this. And look at that. So the point I'm making is really when we multiply binary, when you add a number in let's say you take your cell phone out now, you turn it into a calculator, and you add up two numbers on your cell phone. You enter 2 plus 3. The calculator will take the 2 base 10 and the 3 base 10, convert it to binary, and then it'll add it up. But when you add it up, what are you doing? Well, are you multiplying? Adding is another logic function, which I can show you later. But let's say you're multiplying. You can see that anding, logical anding, all you're doing is really multiplying. So the actual way we show and is, we'll get to this in a couple of weeks, but we'll show and like this. A dot B equals X. That right there means that the and function. And it's the and function because it looks like multiplication. So all on your digital device, when you multiply, there are really and functions in there, and circuits that perform this and logical and you get to multiplication. Now it's a little bit more complicated because what you have is a chip that multiplies, which we can do with an adder, but you got to worry about the carry too. So it can get kind of complicated, but just kind of from a high level looking at this, you can see that this matches this, so the AND circuit comes into play here. So it's really interesting if you guys ever get a chance to dig into this stuff to see how these computer scientists and electrical engineers, how they think about this stuff and come up with this. And this is all based on philosophy. There's a branch of philosophy called logic. And so this all comes from philosophy and math. So the engineers took it and they made computers out of it, but this is all a branch of philosophy. So this is pretty cool. So anyway, I don't want to go off on too many tangents. I know you guys are busy. You don't want to listen to me ramble. That's all I have for today. Does anyone have questions for me about anything I presented today or about anything? Hopefully the quiz went okay. I don't know how that went. Hopefully that went okay. Anybody have any questions or comments before we sign off? Okay, well, you guys take it easy. There is homework 3, I think is due midnight on Monday. It's just this stuff. So look at that, and then I think that's all I have. So you guys have a great weekend, and I'll see you on Monday. If anything comes up, send me a text, send me an email, we'll take care of it, and you guys have a good one.